6 unit. The topic is, so good evening students. Today's topic is paper 6 unit 13. Paper 6 unit 13. Today's topic is paper 6 unit 13, that is carbon disconnection. Carbon disconnection. Today's topic is paper 6 unit 13, carbon disconnection. Okay, then this compound. So we are discussing, first one is one group CC disconnection. Today we are discussing one group CC disconnection. One group CC disconnection. So one group means, or we know already, one group means one function group. One group means one function group. One function group. Carbon-carbon bond undergo disconnection. One group CC means one function group. Carbon-carbon bond undergo disconnection. Okay, this is a one group CC disconnection. So this one group CC disconnection, okay, one group CC disconnection again classified into three types. Okay, 1,1 CC disconnection, 1,2 CC disconnection, 1,3 CC disconnection. Okay, 1,1 CC disconnection, 1,2 CC disconnection, 1,3 CC disconnection. Okay, so 1,1 CC disconnection means, so one function group at first carbon. This is a function group. Function group at first carbon attached carbon undergo disconnection. Function group at first carbon and next carbon undergo CC disconnection. This is a one group CC disconnection. Next, 1,2 CC disconnection. First, in this case, 1,2 CC disconnection. Function group at first carbon. Second carbon CC bond undergo disconnection. Okay, second CC bond undergo disconnection. Okay, this is, and 1,3 CC disconnection. Okay, function group at first carbon, and third carbon CC undergo disconnection. So third carbon undergo disconnection. This is a 1,1 CC disconnection, 1,2 CC disconnection, and 1,3 CC disconnection. Okay, we are going to discussion with 1,1 CC disconnection. Okay, first we are discussing 1,1 CC disconnection. So I am taken here, in this case, this is the example I am taking. This alcohol. When this alcohol undergo function group interconversion. Alcohols are converted into carbonyl compounds. And by involving in 1,1 CC disconnection. Okay. So this is the first carbon and second carbon. These two carbons undergo disconnection. So this is a 1,1 CC disconnection. Okay. So this is a molecule you have to synthesize. So synthesis of this molecule is, when we are taking carbonyl carbon, when reacting with methyl magnesium halide in dry ether, this methyl magnesium halide attack at carbonyl carbon, then forms, so our compound OH. This is a target molecule we have synthesized. Okay, this is 1,1 CC disconnection. Okay, like function group at first carbon, the first carbon and second carbon bond undergo disconnection. This is 1,1 CC disconnection. Another example I'm going to discuss. Another example. So another example I'm here discussing. So that in your notes, that example is. So this is the example in your notes. In this case, this bonds undergo disconnection. This bond again undergo disconnection. So then forms, so first carbon and second carbon undergo disconnection, ketone, and like this, and magnesium halide. Now it is synthesis of this compound from alkyl magnesium halide plus carbonyl compound. Then products are alcohols. This is an example for 1,1 CC disconnection. These are the example for 1,1 CC disconnection. Next, we are going to 1,2 CC disconnection. So 1 to CC disconnection. So first 1 to CC disconnection. Before that, we have some examples. We are taking your notes. One, we are discussing some examples from your notes. One is synthesis of carbonyl compounds. Synthesis of carbonyl compounds. We know already carbonyl compounds are two types: aldehydes and ketones. So what are they? Carbonyl compounds are aldehydes in synthesis. Ketones. These aldehydes and ketones are obtained from when alcohols reacting with alcohols undergo oxidation, the products are carbonyl compounds. Alcohols undergo oxidation, the products are carbonyl compounds. This is an example for synthesis of carbonyl compounds. Carbonyl compounds, either alcohols or aldehydes and ketones. Both are the examples of carbonyl compounds. In your notes, one example is there: cyclohexyl 1-hexyl ketone. Cyclohexyl 1-hexyl ketone is an example. Is example molecule. When this molecule undergo first function group interconversion. So carbonyl compound is converted into alcohol. Function group interconversion. Carbonyl compound is converted into alcohol. Now this molecule undergo 1,1-CC disconnection. 1,1-CC disconnection. First carbon, second carbon undergo disconnection. Then products are carbonyl compounds plus CH3C5H11. These are molecules minus magnesium halides. Okay, this is a molecule. And synthesis of that molecule is synthesis of this target molecule from that carbonyl is cyclohexyl aldehyde. When reacting with the methyl magnesium, that's a Grignard reagent, C5H11, presence of dry ether, undergo here. That addition, the product is, this is a one way to synthesis of target molecule C5H11. Okay. This is example. Next, we are going to discussing synthesis of carboxylic acids. Synthesis of carboxylic acid. How to synthesize this carboxylic acid? When cyano compound undergo hydrolysis, the products are carboxylic acid. Cyano compounds undergo hydrolysis, the products are carbonyl compounds. When that another example is carbon dioxide when reacting with Grignard reagent. Carbon dioxide when reacting with Grignard reagent, the products are, so what are carboxylic acids? So one is synthesis of carboxylic acid is from cyano compounds. Cyano compounds undergo hydrolysis, the products are acids, and carbon dioxide molecule when reacting with Grignard reagent, the products are carboxylic acids. Okay, these are the two examples for synthesis of carboxylic acid. So I'm given one example here in your notes. Some examples are there. I'm taking and discussing here. When phenylacetic acid undergo function group interconversion, this target molecule, when the target molecule phenylacetic acid undergo function group interconversion, the carboxylic acid converted into cyano group. The carboxylic acid converted into cyano group. This cyano again undergo function group interconversion. Benzyl chloride plus sodium cyanide. Benzyl chloride plus sodium cyanide. This benzyl chloride obtained from benzyl alcohol. Now, synthesis of the target molecule is when benzyl alcohol reacting with SOCl2. The product is benzyl chloride. When this benzyl chloride reacts with sodium cyanide undergo loss of NaCl, the product is benzyl cyanide. When this benzyl cyanide undergo hydrolysis, the product is phenylacetic acid is the product. Okay, that means the carboxylic acid are synthesized from cyano compounds. Okay, one example. Another example, your notes. So analysis of para-tolvic acid. Next, this analysis of para-tolvic acid in your syllabus. Analysis of para-tolvic acid. In this para-tolvic acid, so we know already carboxylic acid are obtained from cyano group. Carboxylic acids are obtained from cyano groups and cyano. When the cyano is obtained from, cyano is introducing on benzene ring by conversion of amines. Cyano group is introducing on benzene ring with amines. And these amines are obtained from nitro group. And this nitro undergo function group elimination. The product is toluene. That means simply the target molecule, that is para-toluic acid, are synthesized from toluene. The para-toluic acid synthesized from toluene. Now synthesis of para-toluic acid is when toluene reacting with nitration, toluene undergo nitration with HNO3 and H2SO4 nitration. Para-nitrotoluene is the product. This para-nitrotoluene so undergo reduction with tinin HCl. Nitro is converted into amine when reacting with tinin HCl. Okay, amine. This amine when reacting with NaNO2 and NaN3 in presence of HCl. So nitro is converted, amine is converted to diazonium salts. So what is amine is converted to diazonium salts. These diazonium salts, when these diazonium salts reacting with cuprous cyanide, this amine is azide is replaced by cyanide. Azide is replaced by cyanide. When cyanide undergo hydrolysis, we know already. Cyanide undergo hydrolysis. This cyanide is converted into benzoic acid. So this is a way to synthesis of para-toluic acid. So the starting material is toluene. Toluene undergo nitration with respect to methyl. Nitration takes place at para position. That nitro undergo reduction in tinin HCl. Nitro is converted to amine. And this amine, when reacting with Cl, sodamide and sodium iodide, that amine is converted to diazonium salts. Diazonium salts are reacting with copper cyanide. They converted to cyano. This cyano under hydrolysis, they gives carboxylic acids as the products. Next one is analysis of 2,2-dimethyl propanoic acid. Analysis of 2,2-dimethyl.
Excuse me.
Yes.
So you are taking benzene with 2-methyl group. Reacts with nitric acid, 2-methyl group, and reacts with nitric acid plus H2SO4. So it can react.
No, amine. Nitro is converted into amine. Then amine reacting with HCl and
No. It is not. That is not my question. My question is, you are taking methyl with benzene with 2-methyl group.
Yes, toluene with benzene with methyl.
Is there 1-methyl or 2-methyl?
Only 1-methyl.
Okay. Whether suppose in case of 2-methyl is there, then the 2-methyl is converted into NO2.
No, not possible. It is possible, but nitration takes place according to the position. We are not converting to methyl. We are introducing a nitro group on benzene ring.
Yeah. So my question is whether it is 2-methyl group is there.
No, 1-methyl.
No, sir. Your example is 1-methyl. I am asking whether it is 2-methyl group. Then 2-methyl is converted into NO2 group in the presence of nitric acid and sulfuric acid.
No. It's not conversion. It is introducing function group introducing, not conversion. Okay.
No. I am asking in the second example. Is there a target molecule below the target molecule?
Read second example in your notes.
No. Your written is there. In target molecule is below benzene. Yeah. Benzene and 1-methyl group is there.
Only 1-methyl.
Only 1-methyl. Suppose in the case of 2-methyl is there, then 2-methyl is converted into NO2 group.
No, here not conversion. Is introducing of nitro group by reacting with HNO3 and H2SO4. It is not function group interconversion. It is a function group addition. Okay.
Okay.
So analysis of 2,2-dimethyl propanoic acid. Analysis of 2,2-dimethyl propanoic acid. Now it is 2,2-dimethyl propanoic acid. This analysis of 2,2-dimethyl propanoic acid. When this propanoic acid, when we convert it, undergo function group this is a target molecule. It undergo function group interconversion. Under function group interconversion, that carboxylic acid completely removed by converting into Grignard reagent. And this Grignard reagent is converted into alkyl chloride, alkyl halides, converted into alkyl halides. Okay, now synthesis of this molecule. Now we are going to synthesis of this molecule. So alkyl halides reacting with magnesium.
Excuse me. So could you please, whether it is volume 1 or volume 2?
It's a paper 6.
No, which volume, sir? Volume 1 or volume?
Only so we have is there in paper 6.
No. We have two, volume 1 and volume 2. Organic is that volume 1 and volume 2.
This is second year, first year not, second year.
Is it a second year class?
Yes.
Okay.
Thank you. We are first year student.
Yeah.
You are first year student.
Yeah.
So this is second year class, not.
Okay. Thank you.
What is your name?
Raju.
Okay, right. It is a second year class, not first year. Okay. So you can go and join the first year class only. Okay. So when alkyl halide reacting with magnesium is inserted in carbon and alkyl halide bond, then magnesium halide is the product. So magnesium halide is RMGX is a product. When a Grignard reagent is product, when this Grignard reagent reacting with carbon dioxide and water, then converted to carboxylic acid as the product. They convert into carboxylic acid is the product. Next example is 1,2 CX disconnection. 1,2 CC disconnection. So 1,2 CC disconnection. So 1,2 CC disconnection. Example I am here given you. Alcohol. When alcohols, so that alcohols are undergo, so 1, 2, that function group at first carbon, second carbon and other carbon undergo disconnection like this disconnection. The product is epoxide is the product. The product is epoxide and this is the Grignard reagent. RMGX is the reagent. Now synthesis of this molecule. This is a synthesis of this target molecule from epoxide. Then epoxide reacting with the Grignard reagent R minus MgX plus. So epoxide attacking RMGX attacking on less substituted olefinic less substituted epoxide carbon. Now the bond is breaking takes place. Then product is our target molecule is synthesized under the water condition. Okay, this is a best example for 1,2 CX disconnection. Next one is synthesis of alcohols. Next one is synthesis of alcohols. Synthesis of alcohols to prepare alcohol, which is alkyl halides attached to the beta position. Epoxide route is the best example. So epoxide converted to alcohols. When epoxides when reacting with the Grignard reagent, The product is alcohols. The product is alcohol. This is the best route to synthesis of alcohols from epoxide and Grignard reagent. Okay, this is the best example. So I'm given here. So another example to synthesis of alcohols. Here I am taken one compound here and taken carbon. In this compound undergo 1, 2 CC disconnection. Functional group at first carbon, second carbon and third carbon bond undergo disconnection takes place. Then the product is epoxide. The product is epoxide. When this epoxide, and this is converted into phenyl magnesium halide. Magnesium plus benzene, phenyl is the minus. So again, this epoxide is converted into what is olefins. The epoxide is converted to olefins. Synthesis of this target molecule is when olefins reacting with metachloroperbenzoic acid. So olefins reacting with metachloroperbenzoic acid, the double bond undergo epoxidation. The double bond undergo epoxidation takes place. Double bond undergo epoxidation. Then this epoxide, when reacting with phenyl magnesium halide, phenyl minus magnesium plus, attack at less substituted olefin epoxide carbon. Then opening takes place. The product is alcohols. Epoxide, when reacting with Grignard reagent, the products are the alcohols are the products. This is the best example, and this is the best example. Okay. Next one is 2 group CC disconnection. Next example is 2 group disconnection. Next example is 2 group CC disconnection. So these two group CC disconnection again classified into 1, 2 difunctional compound and 1, 3 difunctional compounds. 1, 2 difunctional compounds and 1 difunctional compounds with the examples, and 1, 5 difunctional compounds. So again converted to 3 types and 3, 4 types. So 1, 2 difunctional compounds again classified into 1, 2 difunctional compounds. Functional compounds. Next one is 1, 4 difunctional compounds. 1, 5 difunctional compounds. 1, 6 difunctional compounds. Okay, we are discussing one by one. So first we are discussing 1, 2 difunctional compounds. 1, 2 difunctional compounds. 1, 2 difunctional compounds. Okay. So in this 1, 2 difunctional compounds, the function groups are at 1, 2 position. The function groups are at 1, 2 position. So here I am given one example is this example. So here the function groups are 1 to each other. Here my function groups are 1, 2 each other. When this compound undergo retrosynthetic analysis, here the bond is breaking like this. Here bond is breaking like this. Here bond is breaking like this. Carbonyl compound and alkyne is the product. So synthesis of this target molecule. When synthesis of this target molecule is when alkane reacting with sodamide liquid ammonia. When reacting with sodamide in liquid ammonia, so base abstract the proton from triple bond carbon, the negative charge. When this negative charge reacting with acetone, so carbon negative charge attack with carbonyl carbon and pi bond shifting towards oxygen side. O minus. When this compound undergo hydrolysis, when reacting mercury oxomercuration reaction, deoxomercuration reaction in presence of mercury acetate and H2SO4, triple bond is converted into carbonyl alcohol. Triple bond is converted into alcohols. OH and carbonyl compound. This is the best example. Next one is benzoyl. Next one is benzocaine. Next example is benzoin. Benzoin condensation. Benzoin condensation. In this benzoin condensation, this is a benzoin condensation. In this case, for example, in benzoin condensation, that undergo functional conversion, the product is aromatic aldehyde. HCN is the product. Aromatic aldehyde, HCN is the product. Okay, these are the examples. And next one is example is analysis of phenyl. Analysis of this compound. Chlorine, ROH, and OH. So when this benzene, when this compound reacting with undergo function group interconversion, this target molecule undergo function group interconversion. Now these bonds undergo cleavage. 1,1 CC disconnection first takes place. 1,1 CC disconnection takes place. Then OH and here ester is the product. In the compound, again function group interconversion. Function group interconversion. Ester is converted into acid. Okay, now we know already acids are obtained from cyano groups. Acids are obtained from cyano groups, and it is undergo they convert into this carbon is converted to carbonyl compound. Carbonyl compound. Okay, now it is now synthesis of this target molecule from paramethyl parachloroestophenol. When we take parachloroestophenol, when reacting with CN, when carbonyl compounds are reacting with CN, then products are cyanohydrines are the products. Then products are cyanohydrines. When the cyanohydrines are the products. When these cyanohydrines, when the cyano is converted when reacting with carboxylic acid, when under water molecule, the cyano is converted to carboxylic acid. The cyano is converted to carboxylic acid. And this carboxylic acid, when reacting with ethanol, so alcohols are converted to esters. Alcohols are converted into esters. And these esters, when reacting with methyl magnesium halide, the product is 1,2 dihydroxy compound. 1,2 dihydroxy compound. So here we are taken 2 moles of methyl magnesium halide. The product is desired product will be formation takes place. Next one is 1,3 difunctional compound. Okay, sorry, here 1, 2 we say is there 1, 2, 1, 3, 1, 4, 1, 5, 6 difunctional compounds are there. Next we are going to 1, 3 difunctional compounds. Difunctional compound. So common in 1, 3 difunctional compound. Best example is 1, 3 dihydroxy compound, 1 beta hydroxy carbonyl compounds, and alpha beta unsaturated carbonyl compounds are the so many examples are there. First we are discussing 1, 3 dicarbonyl compounds. Okay, 1, 2, 3. 1, 3 difunctional compounds. I am taken 1, 3 dicarbonyl compound. When this 1, 3 dicarbonyl compound undergo 1, 3 CC disconnection. 1, 3 CC disconnection, then the product is the bond is weakened like this, then forms negative charge here and the positive charge on here. The positive charge on the carbon, positive charge on the carbonyl carbon. Okay, when it is so now here these are synthons. Now synthetic equivalent is we are introducing one hydrogen here and we are introducing one halogen here, positive charge carbon. Now synthesis of this compound is when acetone reacting with base, proton abstract from alpha position of carbonyl carbon. It's a stabilized by resonance. The negative charge will be developed with alpha carbon, and this negative charge undergo resonance. Enol formation takes place. This enol when react converted into again alpha negative charge. When this reacting with acid chlorides and replacement of chlorine takes place, then attacking here, then the product is 1,3 difunctional compounds. 1,3 difunctional compounds are 1,3 dicarbonyl compounds are the products. Okay, next example is synthesis of beta hydroxycarbonyl compounds. Synthesis of beta hydroxycarbonyl compound. And in this case, here also same that here also 1,2 cc disconnection takes place. So 1,2 cc disconnection takes place. Then again negative charge at here, and positive charge on hydroxy group attached carbon. Now it is converted into carbonyl carbon, and it is converted into acetone. Same when acetone reacting with base, base subtract the proton from alpha position, then produces alpha carbene anion. This alpha carbene anion stabilized by resonance. They forms enolate is the product. This enolate is when reacting with aldehyde. Aldehyde is converted into alcohol. This is the second example. And third example is alpha beta unsaturated carbonyl compounds. This alpha beta unsaturated carbonyl compounds undergo function group interconversion. Then the product is beta hydroxycarbonyl compounds. Then this beta hydroxycarbonyl compounds again undergo cleavage like this. Then forms acetone and when acetaldehyd is a product. Same again, acetone when reacting with base. Base subtract the proton from alpha carbon, then forms alpha carbene anion. This alpha carbene anion when reacting with aldehyde, acetaldehyde. So then product is beta hydroxycarbonyl compounds. When these beta hydroxycarbonyl compounds in presence of acid medium undergo elimination of water molecule, the product is alpha beta unsaturated carbonyl compounds are the product. Alpha beta unsaturated carbonyl compounds are the products. These are the examples for 1,3 difunctional compounds. Okay. Next we are going to discussing 1,4 difunctional compounds. 1,4 difunctional compounds. Next we are discussing 1,4 difunctional compounds. So 1,4 difunctional compounds. We are discussing 1,4 difunctional compounds. In this 1,4 difunctional compound, the two function groups are so 1,4 difunctional compounds. The two function groups are 1,4 position takes place. Okay, here best example is 1,4 dicarbonyl compounds. Best example is 1,4 difunctional carbonyl compounds. 1,4 dicarbonyl compounds. 1,4 dicarbonyl compounds. In this 1,4 dicarbonyl compounds undergo 1,2 cc disconnection. 1,2 cc disconnection. 1,2 cc disconnection takes place. Then negative, then forms here negative, positive, negative, positive, negative, and here negative charge synthon, and here positive charge. This is a product. Okay, when it is synthetic equivalent is for this compound is hydrogen we are added. For positive charge we are added negative charge. For positive charge we are added negative charge. This is an example. And synthesis of this target molecule. Now we are going to synthesis of this target molecule from acetone. when acetone reacting with alpha chloroacetone, when acetone reacting with alpha chloroacetone, this acetone first reacting with base subtract the proton from alpha carbonyl carbon, then produces alpha carbonyl carbon. This carbonyl carbon may replace the alpha chloro in acetone, then product is 1, 2, 3, 4. 1, 4 difunctional compound is a product. So next we are discussing second example for 1, 4 difunctional compound is, so gamma hydroxy carbonyl compounds. Gamma hydroxy carbonyl compounds, alpha, beta, gamma hydroxy carbonyl compound. When this gamma hydroxy carbonyl compound, this alpha beta bond undergo disconnection. There is 1,2 CC disconnection. 1,2 CC disconnection. Then the product is, so negative charge on alpha carbon and a positive charge on beta carbon. Positive charge on beta carbon takes place. So positive charge on beta carbon takes place, and your lone pair of electron present in oxygen transferred to positive charge carbon. The product is epoxide is the product. The product is epoxide is the product. So when same, this is the synthetic equivalent for is acetone. When this acetone reacting with base, we know already, when acetone reacting with base, sodium hydroxide or potassium hydroxide, K2CO3, you take sodium hydride, any base you take. I am taking sodium hydroxide. Base subtract the proton from alpha position of carbonyl compound. The product is alpha carbene anion. This alpha carbene anion, when reacting with epoxides, this negative charge attack at less substituted epoxide carbon, then forms opening of epoxide from less substituted side. Then the product is alpha, beta, gamma. Gamma hydroxy ketone is the product. This is an example. And the second and third example in your book. So that is 1, 2 dicarbonyl compounds. Third example I am taken here. And this is I am taking the third example in your book. This is the third example. When this compound undergo function group interconversion, disconnection of bonds. So that is negative, positive, negative, positive. Then bond disconnection 1, 2 CC disconnection takes place. Then product is, so COOET minus and plus. This is a compound. Now it is synthetic equivalent is synthetic equivalent. This is a synthan for this is synthetic equivalent is this is synthetic equivalent. Okay. When this compound, our synthesis of target molecule from this compound. When this compound reacting with base, base subtract the active methylene group. That methyl group is located in between two function groups, electron withdrawing groups. Then therefore this is called active methylene group. The when base reacting with active methylene group, base subtract the proton from here, produces negative charge. This negative charge when reacting with that chloroacetone, this negative charge undergo displacement takes place. The product is target molecule is this target molecule we have to synthesize. Next one is 1, 5 difunctional compounds. 1, 5 difunctional compounds. In this 1, 5 difunctional compounds, so that is the two function groups are at 1, 5 position. This is mainly we are discussing in alpha, beta, and such carbonyl compounds, and there's Manich reaction. We are discussing in Manich reaction cases. So I'm taking here 1, 5 dicarbonyl compounds. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The two carbonyl groups are 1, 5 position is there. When it is undergo, 1, 2 CC disconnection. Undergo 1, 2 CC disconnection. 1, 2 CC disconnection. Disconnection takes place like this, and here negative charge you know already, and positive charge on third carbon, positive charge on third carbon, positive charge on third carbon. So the synthetic equivalent, this is a synthetic equivalent is we are introducing H plus, and for synthetic equivalent is elimination of the proton, the product synthetic equivalent is alpha beta unsaturated carbonyl compound is a synthetic equivalent. Alpha beta unsaturated carbonyl compound is a synthetic equivalent. When synthesis of this target molecule, we are going to discussing synthesis of this carbonyl target molecule. When acetone reacting with base, when acetone reacting with base, we subtract the proton from here, then produces alpha carbene anion. This alpha carbene anion reacting with so alpha beta unsaturated carbonyl compound undergo Michael addition. The product is 1,5-difunctional compound is the product. 1,5-difunctional compound is the product. Okay. This is a basic one example. I'm going to a second example in your notes. Cyclohexanone derivative. I'm taking a cyclohexanone derivative. This is a compound. When this compound is undergo disconnection, the product is carbonyl carbon and diethyl malanoate. Diethyl malanoate. Okay. Diethyl. Cyclohexanone, alpha beta unsaturated carbonyl cyclohexanone plus diethyl malanoate. When the starting material and when reacting with diethyl malanoate, when reacting with base, we subtract the proton from here. Then negative charge attack at malanoate, active position, and this negative charge when reacting with carbonyl compound, when attacking carbonyl compound, there is a beta position of carbonyl compound, that is a Michael addition reaction. Then product is, this is a product. When this compound, when hydrolysis, under hydrolysis, so now both esters are converted into carboxylic acids. Both esters are converted to carboxylic acid. Upon heating, one of the carboxylic acid is converted into carbon dioxide and hydrogen. Then product is our target molecule is the product. The target molecule is the product. Next one is, last one is 1,6 difunctional compound. 1,6 difunctional compound. 1,6 difunctional compound. So 1,6 difunctional compound. Next example is retro disorder. So when this compound 1,6-dicarboxylic acids, 1,6-dicarboxylic acid undergo converted into functional group interconversion into cyclohexene. This cyclohexene undergo Diels order transform. The product is alpha 1 beta dienine dienophil is the product. So dienine dienophil is a product. How to? Yes, we are going to. So synthesis of this target molecule. Now going to synthesis of this molecule. So butadiene when reacting with dienophil, dienine dienophil when reaction takes place, dienine dienophil, the product is cyclohexanone is the product. When the cyclohexanone undergo ozonolysis, the bond, the double bond, each double bond carbon converted into carboxylic acid. Each double bond carbon is converted into carboxylic acid. Okay? Each double bond carbon is converted to carboxylic acid. So this is a 1,6 difunctional disconnection. Okay, this is the today topic. Okay, next class we are continuing. Next class.
Excuse me, sir.
Tell me.
Sir.
Tell me.
Sir, I have a doubt, sir.
Tell me.
Sir, in the last video you explained about unit 12, sir. In that unit
12. Yes, sir.
Yes, sir. In the page number 235, there is a question, sir. We didn't get the answer for the
235.
Yes, sir.
Which question?
Fourth question, sir. We don't know the answer, sir.
Okay, I will send in your group. Okay.
Yes, sir. The fourth question.
All compounds or any specific compound? All compounds.
Yes, sir. All compounds. Sir.
Okay.
Yes, sir.
Okay, I will definitely I will send you for your and your friends. I will send to your friends. Okay.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you.